of alkanes. Okay, if anyone is watching the live, just give me the hi in the comments. Okay, I believe I am perfectly audible and visible to each and everyone. Okay, fine. Harshad and Prashant, hi. Fine. Okay, let's quickly go to our topic. That's about the chemical properties of alkenes. Yesterday in the previous class, we have studied about the isomerization and nomenclature, right? IUPAC nomenclature and isomerization of the alkenes. I hope it was clear for everyone. And because of the time limit, I have just go through the preparation of alkenes, right? So here I will just give the summary of the preparation of alkenes, as you can see over here, right? Hi Chantana. Okay, here is the different method of preparation of alkene. First one, it is hydrogenation, right? From the unsaturated hydrocarbons, right? From the unsaturated hydrocarbons, we can prepare the alkenes or the saturated hydrocarbons by using hydrogen, right? It's a 1 hour live, 5 to 6. Harshad. Okay, then we have studied about the preparation of the alkanes from the alkyl halides. There will be two methods, right? First one, it is the decarboxylation reduction, right? This is the reduction method by using zinc. Then the another method is very important because it is a name reaction. That is known as the Woods reaction. I hope the Woods reaction was clear for everyone. In this Woods reaction, we will be taking the alkyl halide, right? In which we are using the sodium metal along with the dry ether. So we will get the hydrocarbons, right? We will get the saturated hydrocarbon having even number of carbon atoms. Now let me move to the next method of preparation of alkene from the carboxylic acid, right? Carboxylic acid. There are two methods that I have already taught you. First one is the decarboxylation method, right? In the case of decarboxylation method, the sodium or potassium salt of carboxylic acid, right? RCOH or the RCONA, treating with soda lime, which means NaOH and CaO. It will releases carbon dioxide to form the alkane, right? Alkane or the saturated hydrocarbons having one carbon atom less than that of the reactant, right? One carbon atom less than that of the reactant. Then the last method of preparation from the alkyl halide is the Cohn's electrolysis method. This method is also very important because it is a name reaction. As we can see over here, the sodium salt of carboxylic acid, right? It will undergo electrolysis to produce the even number of carbon atoms, to produce the alkene having even number of carbon atoms at the anode. Then hydrogen gas is produced at the cathode. Clear? This we have already discussed in the last class, right? Yesterday. Hi Rana, good evening. Hello Arya, good evening. Yeah, I'm fine. What about you? Now let us directly talk about the physical properties of alkanes. Right? Ready? What are the physical properties of the alkanes? So, in the physical properties of alkanes or the saturated hydrocarbons, we will be going to discuss about the boiling point, melting point there, and their solubility, right? And their solubility. So, in general, we can say that the boiling point, right? Boiling point of alkanes are depending upon their molecular weight. As the molecular weight increases, their boiling point increases, right? Okay, only 3 is watching, right? Maximum, you can share maximum to your friends also so that we can increase the views. Harshad. Actually, I am not comfortable with Hindi. I can talk in English. If you have any doubt, you can ask. I will tell everything in English multiple times. Okay, here boiling point, right? Boiling point is directly proportional to the molecular weight, which means that as the molecular weight increases, boiling point also increases. Right. Then one more thing is that if the branching, we have already studied about the isomerism, right? There will be chain isomers, which means that there will be branching of the hydrocarbons happens. So if you are taking any of the isomers, if the branching increases, what happened to their boiling point? It decreases, right? Because there is an inversely proportional relationship. Let us talk about with some examples. So these are the isomers, right? These are the isomers of which hydrocarbon? Which alkane? Pentane, right? Because it is a 5-carbon compound, so it is a pentane. We can see that there will be 3 isomers of the pentane. First one, it is normal pentane, then isopentane, neopentane. We can discuss the boiling point of these particular isomers according to their branching, right? According to their branching. So here, boiling point is also given here. For the neopentane, I have already mentioned that if the compound containing CH3 4 times, right? If they are containing this part, we can call it as neo group, right? Yes, normal pentane having more boiling point because of their less branching, right? It is a straight chain compound, there is no any branches. As the branching increases, boiling point decreases. So here in the case of isopentane, this will be our part iso, right? CH3 twice, there is a iso part. In the case of isopentane, there will be one branch is present because it is a 2-methyl butane, right? So what do you mean by neopentane? Here 4 branches are present, right? 4 branches are present. As the branches increases, boiling point decreases. So we can say that the order of boiling point of isomers of pentane starts from neopentane having very less, then isopentane, then normal pentane. Clear? Based on this particular property, you may get more questions in the JEE Main exams. Is that clear? No, there is no need to remember, right? There is no need to remember the particular boiling point. You must have the idea about the branching, right? By the name, you have to identify is the compound containing branching or not, right? Clear? Aryank? Now let us talk about the solubility property of the alkenes, right? As we already know, all the alkenes are non-polar in nature, right? Non-polar in nature. So there is a property like that, like dissolves like, right? If a compound is non-polar, it will dissolve in the non-polar solvents, right? If any compound is polar compound, they will dissolve in the polar solvent. So because of the non-polar property of the alkenes, these alkenes are always dissolved in the non-polar solvents. Clear? Like dissolves like. The last point about the physical properties, right? Based on the number of carbon atoms from C1 to C4, which means methane, ethane, propane and butane, right? These 4 hydrocarbons are gases, right? C1 to C4 it will be gases. Then C5 to C17, starting from pentane, it will be liquid. Then higher members are just like C18 compound, C18, C19 and so forth. It will be solids, right? Clear? Here you want to memorize some of the terms. Okay, fine. Now last property is about the melting point, right? Melting point. There is a data is given here. As you are observing here, right? This is our methane, CH4. Then ethane, propane and butane. What you are observing here, this is our melting point. So, as comparing ethane and butane, right? Ethane and butane, it is having high melting point, right? High melting point. In case of methane, it will be 90.5. For propane, it will be 85.3. As compared to those two, ethane and butane having relatively higher melting point, right? So, we can predict that if any of the hydrocarbon or the alkene, any of the alkene which containing even number of carbon atoms, right? even number of carbon atoms having slightly higher melting point, right? Slightly higher melting point. So, in terms of melting point of alkanes, we must remember that most of the alkanes having even number of carbon atoms, starting from ethane, butane, hexane, like that, it will have slightly higher melting point. Clear? Just let me know in the comments if it is clear. Okay, fine. Now we will be moving to the next important topic or concept, that is about the chemical properties of alkanes, right? This is very, very important. Some of the name reactions as well as very important questions will be come from this particular topic, that is about the chemical properties of alkanes. Ready? While watching this particular session, try to make your own note, right? Try to practice along with me and make the notes. So, in the case of chemical properties of alkenes, we are going to discuss about these 7 types of reactions, right? First one, it is the substitution reaction, then combustion, controlled oxidation, isomerization, aromatization, reaction with the steam, and last one, it is pyrolysis. Ready? Let us start now. Yes, let's start with the first reaction, that is substitution reactions, right? Substitution reactions. What do you mean by substitution? Something is replacing, right? Instead of something, some of the atom or group, anything is replacing that place. So, in case of substitution reaction, we need to start with the halogenation, right? Halogenation, which means that in the case of halogenation, instead of hydrogen, there will be hydrogen in the case of alkenes, right? So, any of the hydrogen will substitute by the chlorine atom. So, this is a substitution reaction in which halogen atom is substituted by the hydrogen, right? So, here I am taking the simplest alkane, right? CH4, right? That is our simplest alkane, known as methane, right? So, what will be our reagent? Halogen, right? So, I am taking here chlorine. I will be starting with the chlorination. What may be the products? Any idea? I have already mentioned that there will be a substitution happening. Any of the hydrogen atom present in the methane will be substituted by the chlorine. Then what will be the products? Yes, CHCl3, right? CHCl3 or CH3Cl? Aryank, CH3Cl, right? Because carbon is having 4 hydrogen atoms here. If I am taking here, right? So, if I am adding chlorine here, for example, if I am taking this hydrogen, right? This hydrogen is replaced by the chlorine atom to form. Then this hydrogen will comes with the another chlorine atom to form HCl, right? So, this will be the reaction. Then, for the halogenation reaction or the chlorination reaction, one of the catalyst, like catalyst we have to be used. Here the catalyst used must be high energy photon, right? High energy photon. So, we can take it as H nu. I think you have an idea about the photon, right? In your structure of atoms chapter. HNU, high photon or ultraviolet radiation or the sunlight, right? Yes, HNU. So, if you are taking substitution along with any of the halogen, you must take HNU as the catalyst here. Clear? So, we may think that this will be our product, right? So, in this particular reaction, it is happening like that. This process continues, right? This process continues. If I am taking chlorine again in presence of HNU, what will happen? The remaining hydrogen, right? One of the hydrogen from here goes with the chlorine to form HCl. Then it will be forming CH2Cl2, right? CH2Cl2. Then again, another chlorine to form CHCl3, right? CHCl3. At last, chlorine react with CHCl3 to form CCl4, carbon tetrachloride, right? CCl4. The reaction continues till all of the hydrogen atoms substituted by the chlorine atom. Clear? The first step, it will be substituted by the first hydrogen atom, then the next one, then third one, then fourth one. Finally, it will move to the CCl4. Clear? Okay, fine. Now you have to try these particular halogenation, particular chlorination with ethane molecule. What will be the product you are getting? The thing is that the reaction will continue till all the hydrogen atom that is present in the alkene will be substituted by the chlorine atoms. Clear? So just let me know how many products will be formed after the halogenation of ethane molecules. What will be the final product? Only 4 products. In the case of ethane molecule, there will be 2 CH3 group, right? So in the first case, CH3, 3 hydrogen atoms present in the carbon will be substituted by 3 chlorine atoms. Then the second step, it will be again another CH3 molecule will be substituted by the other 3 chlorine atoms, right? So in final, it will be getting the product like CCl3, right? CCl3 or C2Cl6. Try to get the product. Write it down the halogenation of ethane. Then just check whether it is getting the final product as here. Clear, Aryan? Okay, fine. So in general, if you are taking any of the reaction, we will get 1 or 2 products, right? But in the case of halogenation of the substitution reaction, many more products are getting due to this particular mechanism, right? Let us see the mechanism in detail. I hope you must have idea about the free radicals, right? Free radicals, homolytic cleavage, heterolytic cleavage. You must have been studied in your first chapter, I mean organic chemistry first chapter. Hi Girnath, good evening. Okay, here this is our Cl2 molecule, right? Cl2 molecule we are adding for the halogenation, we are adding Cl2. So here we can say that one bond represents by 2 electrons, right? One bond means it will be 2 electrons. Yes, it is homolytic cleavage, right? 2 electrons, which means that the chlorine is, this bond is breaking like this, right? Equally it is broken, so we will get 1 electron on the 1 chlorine atom and another electron on the another chlorine atom. So this type of cleavage is known as homolytic cleavage, and the resulting product is known as the free radical, which is having unpaired electrons, right? So we can call these as the chlorine free radicals. So in the first step or in the initiation step, the halogen will undergo homolytic cleavage to form particular free radicals, right? Abhinav, which point I want to repeat about homolytic cleavage or the first step? I think it is about the homolytic cleavage. So, for example, if I am taking, okay, I will write here. This is my compound having a single bond between A and B, right? For example, if I am breaking this particular covalent bond equally, right, which means that 2 electrons are present in the single bond. So, it will break to form A dot plus B dot, right? So, 2 electrons are present, so equally it is breaking to forming A dot plus B dot. These products are known as free radicals. So, this particular cleavage is known as homolytic cleavage or homolysis. Clear? So, here we are taking the chlorine molecule because Cl2 molecule is a covalent bond. It is having 2 electrons, it is equally breaks to form homolysis to form the chlorine free radical. In the second step, these chlorine free radical, right? The chlorine free radical will combine with our alkane molecule, right? Here I am taking the example of CH4. So, it will form CH3 free radical plus HCl, right? CH3 free radical plus HCl. If I am taking like this, what is happening here? Again homolysis happened, right? So, here we are getting the CH3 free radical, right? Then this hydrogen and chlorine free radical combine together to form the HCl. This will be our second step, right? Second step. That particular step is known as chain propagation step. After getting the methyl free radical, right? CH3 dot is known as the methyl free radical. It is again combined with the Cl2 molecule to form CH3. Okay, there is a mistake. It will form CH3Cl, right? CH3Cl plus Cl dot. Clear? Then last step, it is about the termination step. As you can see over here, again the chlorine molecule is chlorine free radically combined to form the chlorine molecule. Then methyl free radical can also combine to form the ethane molecule. Then the last step, one of the methyl free radical is combining with the chlorine free radical to form CH3Cl, right? If you are not getting the mechanism, no need to worry. You must have idea about the product forming, right? Okay, Aryan, prepare well for your exams. April 8, right? Okay, you have more time. I mean, time is there, right? So, try to practice the previous year questions. Is that clear now? Okay, so we have discussed about the halogenation in presence of chlorine, right? Chlorination we have discussed. Then we have already known about the halogens. It will be including bromine, chlorine, fluorine and iodine, right? Then what will be the role of fluorination in, okay, what will be the reactivity of the fluorination, right? So in general we can say that fluorine is highly reactive, right? Highly reactivity. So we can say that the reactivity of halogens towards alkanes will be maximum in the case of fluorine, then chlorine, then bromine, then finally this iodine, right? Clear? So now in the case of substitution, I have already mentioned that hydrogen atom is replacing, right? Hydrogen atom is replacing by the halogen. So we must have an idea about the primary, secondary and tertiary halogens, right? Primary, secondary, tertiary hydrogens. What do you mean by tertiary hydrogen or tertiary carbon. So if I am considering this carbon, right, if I am considering this carbon is connected to 3 other carbons, right, 3 other carbons. So we can call it as tertiary carbon, right, tertiary carbon, because this carbon atom is highly connected to 3 other carbon atoms, so it is known as tertiary carbon. The hydrogen that is bonded to the tertiary carbon is known as tertiary hydrogen, right, tertiary hydrogen. Then what about here, if I am considering this carbon, right, for these particular carbon, how many other carbon atoms are connected? This is about the substitution reaction, right? So the rate will be starting from the fluorine only. It's not about the size concept. In the second case, this carbon atom is connected to other 2 carbon atoms, right? So I can call these particular carbon as the secondary carbon, and these hydrogens are known as the secondary hydrogen, right? Secondary hydrogen. Now, if I am considering this carbon, right? If I am considering this carbon, this is connected to only 1 carbon, right? So I can call this as the primary carbon, or these 3 hydrogens are known as primary hydrogens, right? Primary hydrogens. Only this carbon. So if you are taking about the replacement of hydrogens or the halogenation, right? Halogenation with the different types of compounds, you can say that tertiary hydrogen will replace easily than the secondary, then primary. Then one more possibility is there about the methyl group, right? Methyl. Clear? Okay, I will see one question about this application of this particular topic after the session. Okay, I hope it is clear for everyone. Now let me move to the next part. Okay, fine. Now let us talk about the combustion reaction, right? What do you mean by combustion? What will be the reactant? Here we are discussing about the combustion of alkene. So we can say that alkane is reacting with oxygen, right? Alkane is reacting with oxygen. So what will be the general product? We can say about that size also, fluorine and fluorine is small in size, there will be repulsive. But in terms of electronegativity also, we can define it very neatly. In general, fluorine is very violent. It can be very uncontrolled reaction, right? And for Aryan and Girinadh, your way of thinking is good. Okay, what about the combustion? We are reacting with the Oxygen, right? So in general combustion reaction, what will be the product? Carbon dioxide and water, right? Carbon dioxide and water will be the general combustion reaction product, right? Hi. Okay, here in the first case, I am taking the simplest alkene, that is methane, right? Methane CH4. Now I am reacting with the oxygen, right? During combustion reaction, I am reacting with the oxygen. What will be the product? In general, it will be carbon dioxide and water, right? Carbon dioxide and water. By releasing a high amount of energy, which is given as delta H is equal to minus 890 kilojoule per mole. So it is an exothermic reaction, right? This is an exothermic reaction. Clear? So in general, if you are taking the combustion reaction, we will be getting the product carbon dioxide and water. You need to balance this equation also. I will give you an idea about the balancing of the reaction. So, what is the ratio of reactant here? In moles. For example, I am taking 1 mole of CH4, right? 1 mole of CH4 here and 2 mole of oxygen. Right? I am getting the same product of carbon dioxide and water. The same reaction I am repeating by changing the mole ratio of oxygen, right? Instead of 2 mole of oxygen, I am taking 1 mole of oxygen here. What will be my product here? What are you observing? What will be the product here if I am changing the mole ratio of oxygen? Instead of carbon dioxide, I am getting carbon black, right? Simple carbon, solid carbon. So this is known as a carbon black. So we can say that this is about the complete combustion, right? Complete combustion. Then if you are doing this particular reaction in the incomplete combustion method, right? Incomplete combustion method, I will get the product as carbon instead of carbon dioxide. Clear? Clear? So what you are observing here, if you change the mole ratio or the ratio of oxygen, here you will get the product other than carbon dioxide and water in the combustion. That particular reaction is known as incomplete combustion. Clear? So now let us talk about the combustion of another alkanes, right? Another higher alkanes. For example, if I am taking any of the other alkane, right? I am doing the complete combustion by adding oxygen. What will be the product? For example, I am taking C4H10, right? C4H10. 4 carbon compound, right? It will be the butane. Now, this is the general trick or general formula to balance the combustion reaction of alkane. CnH2n plus 2, our alkane, right? Then I am adding 3n plus 1 by 2 O2, where n is the number of carbon atoms. I will get NCO2 plus n plus 1 H2. Now try the combustion product. Try to find out the combustion product of butane. What will be the product? With a complete balanced equation. C4H10, right? CnH2n plus 2, C4H10. What is the number of n here? Number of carbon atoms? Number of carbon atoms? 4, right? Yes, 4. So 3 into 4 plus 1, 13, right? 13 by 2 O2 gives NCO2, which means 4 CO2, right? Plus n plus 1, that is equal to 5 H2. This will be our final product with the balanced equation. This particular reaction you can see in your NCERT textbook. Right? Clear? You need to memorize these balancing equation. How to balance the equation. Clear? Now let us talk about the controlled oxidation method, right? In general, oxidation means addition of oxygen, right? Oxidation means addition of oxygen, right? Yes, this live chemistry lecture will be there on every day from 5 to 6, right? Daily. Okay, controlled oxidation, which means we are adding oxygen here. So now you can observe in the first case, in the combustion, right? If I am taking methane and oxygen, I will get the product of either carbon dioxide or carbon black, right? Carbon black, solid carbon. But here in this third reaction, right? In this third reaction, what you are observing the product? I am taking the same CH4, right? Same CH4 and O2, but I will get the product instead of carbon. It will be methanol, right? Methanol. So this will be the product methanol. What will be the change here? I just changed the mole ratio of methane and oxygen. Then this is the main important thing, right? What the catalyst we are using? What is the catalyst we are using here? So this is a particular condition. You need to memorize these particular condition also. If you are taking methane and oxygen in presence of copper at high temperature of 523 Kelvin and 100 atmosphere pressure, you will get the product as methanol, right? Clear? Yes, it is correct. Oxidation is losing electron and reduction is gaining electron in terms of electronic concept, right? Here I am asking about the classic concept in terms of oxygen and hydrogen. That's also correct. Okay, here we need to memorize the catalyst or the particular compound which is using here. Copper at high temperature and pressure, you will get methanol. Clear? So next one, same thing I am repeating, right? I am repeating the same methanol, methane and oxygen, but I changed the catalyst here. I use the molybdenum oxide, right? Molybdenum oxide, by heating, I will get another product, another different product, right? This is our methanol or formaldehyde, right? So these four reactions are very important, right? Depending upon the change in the catalyst we are using, we will get different products, right? Clear? And this is the another case. If I am taking ethane molecule, right? If I am taking ethane molecule, I am doing the combustion or the oxidation using manganese acetate as my catalyst or the reagent here, right? So I will get the product as CH3COH, that is acetic acid plus water. Acetic acid plus water. Right? So in general, in these three reactions, we are adding oxygen. So it is known as oxidation reaction, right? But we are controlling the reaction by changing different catalyst. So this reaction is known as controlled oxidation. Clear? Then here is the next case. It is very important. I am doing the oxidation with KMnO4, potassium permanganate, right? KMnO4, I will get the product as alcohol, right? So we can say that alkanes can be converted into alcohols by the oxidation of KMnO4, but the condition is that the particular compound must contain tertiary hydrogen, right? Tertiary hydrogen. So here, right, CH3 tries. If I am considering this hydrogen, this will be connecting with 3 other carbon atoms to form tertiary carbon containing hydrogen, right? So this will be the tertiary hydrogen. If any of the alkane that is containing tertiary hydrogen atom, we can oxidize this into their particular alcohol by using KMnO4. Clear? Okay, now let me move to the next type of reaction, that is known as isomerization reaction. Isomerization reaction. In the previous class, right, about the isomerization, we have studied about the chain isomers of alkanes. So here the main thing you have to be remember that which is the catalyst is using here, right? Anhydrous aluminum chloride, right? Anhydrous AlCl3 in presence of HCl. In presence of HCl, if it is using, we will get the isomers of that particular product, right? Isomers of that particular product. For example, I am giving the isomerization of butane using the particular compound anhydrous AlCl3 and HCl. We will get 2-methyl propane, right? 2-methyl propane, which is the chain isomer of butane. Clear? So, if I am taking pentane, right? I am treating with anhydrous AlCl3 in presence of HCl. What will be the product you are getting? You will get the two types of isomers, right? One may be 2-methyl butane, another will be 3-methyl butane. So we can form it as this will be the major product. Clear? So while discussing about the isomerization of alkane, you need to remember that if you are saying anhydrous AlCl3 in presence of HCl, it should be an isomerization reaction. Clear? Now let us talk about the next type of chemical property, that is about the aromatization, right? Aromaticity, you must have idea about the aromatic compounds, for example benzene, right? If any of the compound that is containing conjugated double bond or the delocalized pi electrons is known as aromatic compounds. In general, we know about the benzene compound, right? So if I am taking hexane, hexane is a straight chain compound, right? Hexane is a straight chain compound. This is our hexane. Here, the thing you have to be remember that this simple trick or the memorization trick, Vikram, right? Vikram, which means if you are taking the oxides of vanadium, chromium or molybdenum, right? Molybdenum. You will get the product as an aromatic compound, right? Aromatic compound. So here I am taking the hexane in presence of either chromium oxide, Ca2O3, or vanadium, right? Vanadium pentoxide or molybdenum oxide at high temperature of 773 Kelvin. This temperature is also important and pressure is also important, 10 to 20 atmosphere. What it is happening, in the first step it will get cyclized, right? These 6 carbon compound gets cyclized to form cyclohexane ring, right? Cyclohexane ring. Then after that it will undergo dehydrogenation, right? Dehydrogenation. First step it will be undergoing cyclization. Then it is about the dehydrogenation, removing hydrogen atoms to form aromatic compound. Clear? So this will be our first compound, hexane. It will be reacting with these particular compound to form the simpler aromatic compound known as benzene. Clear? This particular catalyst is also very important. Similarly, if I am taking heptane, right? This is our heptane molecule. 1, 2, 3, 4, 5, 6, 7 carbon compound, right? So what will happen first? Here it will form a bond, right? First it will form a cyclized compound. Then it is releasing 3 hydrogen atoms, right? 3 hydrogen molecule or the 6 hydrogen atoms to form double bonded compound, right? A benzene ring is forming. This CH3 will be present here. Are you able to understand? Right. So we will be starting with the hexane. Hexane, it will be directly forming the benzene ring directly, right? So if you are taking heptane, 6 carbon atom combined to form benzene, then the remaining carbon compound will be taken as the branching, right? CH3. Now, if you are taking octane, right? Octane, 8 carbon compound. 6, it will be cyclized to form the aromatic compound, that is benzene, right? For example, I am taking C8H18, right? What will happen? This will be our benzene molecule which is formed by the 6 carbon atom. Then how many carbon molecules are remaining there? It may be 2 methyl groups are present, right? It may be 2 methyl groups are present. So I can say that one will be branching like this. Right? 2 methyl groups will be present there. So either it can form 1,2 position or ortho compound, right? This will be ortho, this will be meta, and this will be para. These particular compound that in which 2 methyl groups are present in the benzene is known as xylene compound, right? So this is known as orthoxylene. So in the aromatization of octane, you will get different 3 products. Is that clear, Aryang? Okay, we are moving to the last reaction, that is about the reaction with steam, right? As we already know, steam means gas molecules of water, right? Vapor gas, vapor water, right? So here I am taking the water molecule in gaseous state. It will result in the product of carbon monoxide and hydrogen gas, right? Carbon monoxide and hydrogen gas. The condition is that at high temperature we are using nickel as the catalyst. 1273 Kelvin in presence of nickel catalyst, you will get the product of carbon monoxide and hydrogen. In this particular method, we are getting the hydrogen atom, right? Hydrogen gas. So this method is also used for producing the industrial preparation of dihydrogen gas. Clear? You need to remember this equation only. This condition is very important. Then about the last reaction, that is about the pyrolysis. If you are heating any of the higher alkenes, right? If you are heating any of the higher alkenes, you will get the lower alkene product, right? You will get the lower alkene product at high temperature. For example, if I am taking ethane molecule, right? Ethane molecule, I am heating about high temperature of 450 degrees Celsius. I will give the product as C2H4 plus H2, right? C2H4 plus H2. Then another condition, if I am taking hexane molecule, right? C6H14, I am heating this particular compound in presence of high temperature, 773 Kelvin, right? 773 Kelvin. 3 different products that I am observing, right? First one, it is hexene, right? C6H12 plus H2. Then it will be 2 alkenes. One is butane and another one is ethane. Then last one, propane, ethane and methane. Clear? In this particular topic, you may get the question about that. If you are giving this compound, right? If you are giving this compound, what will be the next product? You can just minus from the carbon and hydrogen atoms, right? Here it is C4, remaining 2 carbon is present. Then here it is 8 hydrogen, remaining 6 hydrogen is present. So you will get the product of C2H6. Clear? So in this particular method, higher alkenes are breaks, right? Higher alkenes are breaks to lower alkenes by heating. So it is breaking. So this method is also known as cracking. Clear? Okay. Few more questions are given here. Just give me the answer in fast. Only 5 more minutes are left. This is based on the soda lime decarboxylation. Sodium salt of X is heated with soda lime to give ethane. What will be the X given here? Soda lime means Soda lime means NaOH plus CaO, right? So here we are removing the carbon dioxide. So in general, we will be getting the product as one carbon atom less than the sodium salt, right? So here we are getting the 2 carbon compound. So our sodium salt will be having 3 carbon atom, right? So propanoic acid will be the correct answer. Option 3. Here is the next question about the Woods reaction. What will be the product? What is the product will not get by the Woods reaction between ethyl iodide and propyl iodide? Woods reaction means we are treating the alkanes with the sodium in dry ether, right? So in first step, it will get doubled. So we will get butane. Then propyl get doubled, it will form hexane, right? Then these two again combine together to form 5 carbon compound, right? Pentane. So these are the products in between the Woods reaction. Here in this option, propane will not be the product, which means option 2 will be the correct answer. We have only limited time, that's why I am going very fast. Then what about this question? This question is based upon the branching of compound, right? So if I am taking boiling point here, I am taking the isomers of pentane, right? So just find out the point here. If I am taking neopentane, there will be more branches, so it is having very less boiling point, about 9.5 degrees centigrade. So first compound will be neopentane, then it is isopentane, then n-pentane. Clear? Here is the next question, which is based on the chemical properties. What will be the catalyst which is used in the aromatization of normal hexane? Aromatization of normal hexane. Vikram, right? Either vanadium oxide or chromium oxide or molybdenum oxide. So option 2 will be the correct answer here. Here is the next question. This is a statement based question. Read the statement carefully. I will be just give the answer first. So here it is 2-methyl butane, right? 2-methyl butane. It is about the oxidation with KMnO4, right? While you are discussing about or writing about the structure of 2-methyl butane, you can observe that this particular compound containing tertiary hydrogen, right? Tertiary hydrogen. So I have already mentioned that if any of the alkane that is containing tertiary hydrogen, it will result in the corresponding alcohol by using the oxidation of KMnO4, right? So the statement 1 is correct. If you are taking any other alkenes like normal alkenes, we will not get the product. We will not get the alcohol, right? So statement 1 will be correct. Statement 2 will be incorrect. Which means option 3 is the correct answer. Here is the last question, taken this as the homework. We have already discussed about the substitution reaction, right, or halogenation. Here we are discussing about the bromination. So this will be our compound, right, 2-methyl butane. What will be the product which is happening at the bromination? I have already discussed about the rate of reaction, right? We are forming the tertiary, secondary and primary hydrogen. So in first case, tertiary hydrogen will be replaced fast as than the secondary and primary hydrogen, right? So option 4 will be the correct answer here. No, live is coming on. No? From 6 to 7, there will be maths lecture. So Pratnya ma'am is waiting here. So that's all about from my side for today. Then there is a reminder about the AATS. Link will be given in the description. You can take the link and enroll the AATS series. So I hope it was clear for everyone. In the next class, I will be discussing about the alkene, right? Another unsaturated compound containing double bonded. So see you in the next session. Till then, bye bye all of you. Thank you so much.